Hi, I'm Marcus.
Hi, I'm Jacob, and today we're going to show you how to build a operational amplifier, audio amplifier.
This is our audio amplifier. Well, yes.
This is the schematic for our audio amplifier. Essentially, it consists of 4 individual operational amplifiers with a supply voltage of plus and minus 9 volts on each of the amplifiers. The 2 resistors going across each amplifier control the gain of the circuit. For these operational amplifiers, these are hooked up in inverting amplifier mode. The gain becomes the upper resistor divided by the input resistor. So for our first op amp, the maximum gain, so we have a potentiometer on the top, is about 50, whereas on the secondary op amp, the gain is 0.047. The overall gain of our amplifier is about 2.35. Audio signals are alternating current, which means that the voltage goes between a plus and minus supply. So here in this clip you see that I have my iPod connected to the potentiometer and it shows the waveform.
Since audio signal is an AC input, you have to build a dual power supply to power the op amp.
We have a plus side, a minus voltage side, and a virtual ground. And the ground from our audio signal will have to be connected to the virtual ground, so we have a reference between plus and minus for our operational amplifiers.
Here's a picture of audio amplification with our amp amp. Input signal is shown as B of X with square on the sine wave, and it's amplified on the output signal as C of X with triangle marking the lines. You can see the amplification from the 2 signals.
This clip here shows a oscillating and sweeping input into our amplifier. And when you adjust the gain of the amplifier, you can see how the input signal in yellow is being amplified and shown as the output signal in blue. Yes. So this is our amplifier as a whole. You have your input signal here and your output signal connectors here. This is where you'll connect it to the supply. This part right here is what generates our plus and minus voltage and our virtual ground force to use for our amplifier, which is over here. Essentially, this starts out as it takes positive 18 volts from here, runs it through this first resistor, runs it through the second resistor. Each resistor drops 9 volts off of the power. So if you measure from the middle to here, you have plus 9 volts. If you measure from here to here, you get negative 9 volts, as long as you use this as your reference. So as long as you connect this side to your positive rail and this side to your negative rail, you can generate a split rail voltage reference to here.
This is where we discuss the amplifier section of our breadboard, where we have the 2 amplifiers here and here, and our reference resistors here, and our controlling volume or gain control for our resistor hooked up to our inputs for the op amps, and our first and second stage, which then have an output to our output signal, and we have our input for our input signal. We send these through here, amplifying the signal so it comes out louder, maybe even clearer.
So this is the first stage of the amplifier. It uses this 1K resistor here as an input resistor, along with this potentiometer, which is a 50K potentiometer. It's set up to where the 50K is wired from the output to the inverting input of the operational amplifier, with this one going from the from the input signal from your iPod or your MP3 player to the op amp. So in order to get the gain, you will you will divide this value here. This can be anywhere from 0 to 50K ohms, and divide it by this 1000 ohm resistor. So for our first stage, you can get a theoretical gain of negative 50. And then from here it goes through this 10K resistor into the secondary stage amplifier. This one takes the inverted signal and makes it positive again, but this one it doesn't really amplify the signal as much as it reduces it, so we don't overload the speakers, and so it sounds much better. This part of the amplifier has a gain of 0.47. I'm sorry, it's 0.047. So between the two, overall, you get a gain of 2.35 before it goes to the output side of our amplifier.